Okay, so law of sines is the next thing after right angle trig. So you can write law of sines either way. So it doesn't matter whether the sides are on the top or the sides are on the bottom, as long as you're consistent, okay? So in the top one, we have the sides on the top. I'm just going to fix this. And then the version at the bottom is with the angles on the top and the sides on the bottom. So it doesn't really matter which way you write it, as long as you're consistent where you put the sides and the angles, okay? I'm trying to fix this microphone so you can actually hear me. It's hard to wear a microphone and a mask at the same time. All right, let's do it this way. Okay, so the only thing that you have to be careful of with sines law is that you have to have a complete ratio. That's the only way you can use it. So generally when I do trigonometry, we always check for right angle first. Right, so that's what we always check for. If you have a right angle, then you are going to use the right angle trig. Okay, so katoa. If you don't have a right angle, then that's when you go to law of sines. So in order to use law of sines, you must have a complete ratio. So if we look at the formula, a complete ratio means you must have both of one of them, okay? So you have to have a side and an angle of one of the ratios. Labeling is important. Okay, the triangle, we use capital letters on the corners, on the vertices, and then we use the same letter, but lowercase on the side opposite. So if this is angle A, then opposite would be side A. If this is B, opposite is side B, and if it's C. So that's really important with law of sines and law of cosines, okay? And it doesn't have to be A, B, C. It could be P, Q, R. It's always the same. If it's angle P, it's side P. So let's look at a question here. Make sure you can hear. Yes, Ethan, I got your email. I forwarded it to Ms. Nagpal, who's your guidance counselor, because I'm not sure if you have to complete a form or I think you have to let the office know. Okay, so here it says determine the length of side A. Okay, so we want the side opposite angle A. So I'm going to use A over side A. I always like to circle which ratios I'm using. So I'm going to use A because I'm asked to find A. And then I see that I know side B and angle B, so I'm going to use B. So we're only going to use 2 of the 3. We don't need the third one because we're not asked to find it. We don't have any information, so we just always use 2 so that we can cross multiply. Once you've done that, you can fill in what is given. So side A we are trying to find. Angle A is given. Side B is given, and angle B is given. And then once we've done that, we can cross multiply to solve for A. So we have A sine 99, 12 sine 43, and then we would have to divide to isolate for A. So when you are calculating these trig, I think I mentioned it last time, make sure that your calculator is in the degree mode. Okay. Because if it's not in the degree mode, you're going to get the wrong answer. So you have a radian mode, which is a different unit, which is what we do in the advanced functions course. But in this course, we always stick with degrees. And so we just type that in, find the value of A. Did I do that one? Yep, so A is 8.3. And make sure you put units if units are given. If they're not given, don't worry about it. But if they're given, make sure you put the unit. So that's just basic find a missing side. We might be asked to find a missing angle. So this one wants to find angle B. So I'm going to use B over sine B. And I'm given A, or C. So I'm going to do C over sine C. I'm not going to do A because I don't need to find it and I don't have any information about A. Then we fill in what we know. So side B is 7. I'm looking for angle B. Side C is 10. And again, we cross multiply. So these two and these two. Okay, so sine B will equal 7 times sine 112 and then divide by 10. I'm going to do cross multiply and divide in one step because I already know I have to divide by 10. And then just make sure that you are doing the inverse because we are trying to find the angle. So we are going to do the inverse of that. I just typed the whole thing in as it is. The more decimals you keep, the more accurate your answer. Okay, and then round at the end. And generally, we round angles to the nearest whole number. So this one would be 40, and that's rounded. Okay, so missing side, missing angle. What else do we got here? You might have to do a couple of steps. Some of them will be multi-step problems where you have to find one measurement in order to find another one. So we want to find angle C. And C is part of this triangle, which is isosceles. Right? They're both sides are 10. So if it is an isosceles, then these two angles are equal, right? So if I can find this angle, it's equal to angle C. If you use an angle and it's not clear what the angle is, you need to use 3 letters to identify the angle. So this one, C is probably pretty obvious, but I'm going to start with B, go to C, and to D. So the middle letter is always the angle, right? So B, if I say D, it may not be clear. So I'm going to say the angle starts at B, goes to D, ends at C. Okay, so these two are equal because it's isosceles. So I also know that these two make a straight line, right? Those two angles make a straight line, which are supplementary angles. So if I can find this angle here in this triangle, then I can subtract it from 180 and find the inside angle. So I'm going to use the green triangle, and I'm going to use A over sine A because it's given. And I'm looking for angle D. I'm going to use D over sine D. So A is 10, 25. Side D is given as 20. And we're going to calculate that. So sine D, if I cross multiply, these two go together, and these two. And then we will inverse that because we want the angle. Okay, so here's the issue. I didn't really mean to pick this one, but the angle works out to be 50, let's say 58. Well, when I look at the diagram, that angle obviously doesn't look like 58, okay? It's called the ambiguous case. So sometimes when we draw triangles, we can draw the same triangle with the same measurements in 2 different ways. You might have looked at ambiguous case in grade 11. So the ambiguous case means it could be 58 or it could be its supplementary angle, which would be, what, 122. So the ambiguous case may apply. Ambiguous. So it's obviously 122. Looking at the diagram, it looks like it's an obtuse. So this inside angle is 122, which makes this one 58, which makes this one 58. So you won't, I won't be giving you any ambiguous cases. It'll be probably the acute angle, but just so you know, that's because it's an ambiguous case, so you have two different answers. Oops. I just picked that question and I didn't really want to pick an ambiguous case, but I did. Okay, so any questions on that? So that's law of sines. I don't see any questions. Okay, if you cannot use law of sines, so you don't have a complete ratio. Oh, actually, I have one more question. Okay, so this one wants to find the length of BC. So BC is part of this triangle. Right, I want to find this measurement. It's part of this right angle triangle. So, and I have the angle. So I need another side, okay? If I want to get another side, I'm probably going to have to use the big triangle. So in this green triangle, right, so we have the green one, and then we have, if we look at the whole thing, right, as the red one, okay? So what can I find? Well, I know, is there any angles I know? I'll erase this. So in this triangle, I know two of the angles, so I could find the third, right? I know 90 and 65, so I could find the third one because I know they add up to 180. So that would be 90 minus 65 is 25. Okay. If I know that angle, I could find this angle, because if I look at the big one, I've got 90 and 20 and half or part of the top one, so I could figure out that one. So we've got 90 plus 20 plus 25 is 145. Okay, subtract that from 180. That would be 35. So I know that angle. So if I know this angle, and I could figure out this inside angle, right? Because those add up to 180. I'll get my calculator here. Okay, so I could figure out all the angles in this triangle because I know I can use the angle. Some of the angles in a triangle add up to 180. So we've got 180 minus 90 minus 20. Right. Okay, so I'm trying to get the inside one. Okay, so the inside one is 130 or 180 minus 65 is 115. All right, so I can figure out all the angles in these triangles just because I have enough information. I want to figure out this side, so I'm going to use this triangle. So I just need another side. Well, this side is common. Generally, you want to use a side that's common to both triangles. So if I could find this side, let's call it B, I could then use the right angle triangle, which is the red one. Okay, in order to find D, I can use the triangle on the right. Let's do this in blue. So I can use this triangle, which is not a right angle triangle, but I could use law of sines. So I can use D over sine D. And we have another, oh yeah, I have 15 over 35. So let's call that A over sine A. Okay, so D is the side I'm trying to find. Angle D is 20. A I know is 15, and angle A is 35. Okay, so we'll find D by cross multiplying and then dividing. And then that will give us enough information in the red triangle to determine side BC. So I'm typing in 15 sine 20 divided by sine 35. So that side works out to be 8.9. Once I have that, then I can use this red triangle to find BC, which is what I'm looking for. I know the angle. I just found this side here, and it is a right angle triangle. So I can just use SOHCAHTOA. I have the adjacent side and the hypotenuse, so I'll use cosine. 8.9. And that's 8.9. And then we'll just multiply that times cosine 65. 3.8. Okay, so you're going to get some questions where you have to find one measurement in order to find another. So you need to sort of work your way backwards and then find what information do I need in order to find the measurement that I'm looking for. Okay. Law of cosines we use if we don't have a complete ratio, right? So our checklist would be, do I have a right angle? Yes or no. If it's no, can I use law of sines? Do I have a complete ratio? If that's no, then we're going to use law of cosines. You, of course, will get the formulas. You don't have to memorize them. There is a pattern. If I want side A, so these are sides. If I want side A, it's the other two sides minus 2 times the other two sides, cosine of the angle that I need, right? So if it's B, it's the other two, A and C, minus 2 times A and C, cosine of B. So let's say we had triangle PQR, and I wanted P. It would be the other two, so Q and R, minus 2 times Q and R, and then cosine of the angle. So there is a pattern. It doesn't have to be triangle ABC. Sometimes if people get PQR, they cross it out and put ABC. I'm fine with that if that makes sense to you. But there is a pattern to the formula. If we want a missing angle, we need to rearrange the formula for the angle. So let's say we wanted to find cosine C. This whole term here is negative. So if I move it over, I can make that positive. But if I move this term to the left, that means the c squared needs to come to the right. So minus c squared. And then we want to isolate cosine c, so we would divide by 2ab. Okay? So that's where these formulas come from. These formulas are just the equation rearranged for the angle, okay? So again, you don't have to memorize it. You can just look at the formula and use it, as long as we are typing it into the calculator correctly. Okay, so one situation where we need to use cosine law is a contained angle. So a contained angle is an angle that is in between two sides. So if I have a contained angle, I don't have a complete ratio. Okay? In that ratio, I only have the angle and I don't have the side. In this ratio, I have the side, but I don't have the angle. And in this ratio, I have the side, I don't have the angle. So if you have an angle in between two sides, you do not have a complete ratio, so you'll have to use law of cosines. So I'm asked to find side x. I'm just going to label this. So I'm just going to put some letters on it, A, B, C. I'm looking for side C, which is across from angle C. So we write out the formula and fill in the measurements that we are given. So angle or side A is 17, side B is 22. Okay, so you can type it all in your calculator in one go if you want, if that's what your calculator does. Just make sure I got the right question here. Just make sure that you are typing in this as one number, okay? Do not, some people do this incorrectly because they They square the 17, they square the 22, they multiply the 2, the 17, and the 22, and then they add all the terms, and then at the end they multiply by cosine 42. But remember that you have to do order of operations. So you have to do multiplication before you do addition, subtraction. So all those terms at the end that are multiplied need to get multiplied together. Okay, so if I square 17, we get 289. If I square 22, I get 484. And then all those numbers multiplied together, 2 times 17 times 22 times cosine 42 equal 555.87. Okay, so now we can add and subtract. So we get 217.13. And then don't forget to square root at the end. Okay, so last step is square root. Like I said, you can type it all in the calculator at once, that's fine. But if you do it separately, just make sure that that last group all gets multiplied first before you add and subtract. Okay, the second case that you're going to use cosine law is if you have all sides and no angles. Okay, because we don't have a complete ratio. So we can't use law of sines. Okay, so I'm looking for angle, let's call it ABC. So I'm looking for angle A. So I'll use the angle formula. And we'll plug in all these numbers, 39. Just make sure that you're putting them in the right spot. If there's an error, it's probably because you interpreted the sides and the angles and you put them in the wrong spot. So just type that all in. Again, you can put them in the calculator all at once. I generally do the top number first, the bottom number, and then do it. So we get 2505 on the numerator. And we get 3666 in the denominator. And then once I've done that, I just have to do my inverse, because we have to find the angle. So angle A works out to be 47. Okay, so a lot of it is, most people can pick the right equation, they can put it in. Sometimes it's the calculator that fails you. Okay, do I have something else here? That's just A length. Okay, so that's just a quick review. I'm going to stop stop there for now. The other part of some of the questions is solving. Just remember that, well, let's say we were going to solve. Let's just do this one here. Okay, so if you see a question that says solve, it means find all missing sides and angles. Right, so solve means find everything that's missing. Doesn't matter what order you do it, but obviously there's going to be an order that makes more sense. So I have an angle in between two sides, so I would have to use cosine law to find that side. That's the first thing that I would have to find. So I would find side x first. So we'll use the cosine law. So the other two sides are P and W. And we'll fill in what we know. So 13, 11. And the angle is 63. So 169, 121. And this works out to be 129.84. So now we can add, subtract those numbers. We get 160.16. And square root, 12.7. Okay, so I found the third side. Okay, so now I have to find angle P and angle W to finish solving the triangle. Since I now know x. So now we know x. Oops. We just found x to be 12.7. Okay, now I have enough information to use the law of sines. So I don't have to continue with law of cosines. I can now use law of sines. If you continue with law of cosines, that's okay. Doesn't really matter. But you are able to use law of sines. So now I found side x, so I can use x over sine x. And angle x was 63, so I can use that. And then I'll just pick an angle. I have to find P and W. It doesn't really matter which one. I'm going to do W. So W is 11. And I want to find angle W. I could also do P. It doesn't really matter. So sine W, let's cross multiply and divide. And we'll do the inverse. So we can just type that in and find that. 11 sine 63 divided by 12.7. And then we want to inverse that. And that works out to be approximately 51 rounded. And then once I know that, I can find the final angle by subtracting the other two that I know. So 180 minus 51 minus 63. So that works out to be 66. All right. So now I've solved the triangle. I found the missing side and the two missing angles. Okay. So that's sort of a couple of steps to do those ones. All right. Are there any questions on any of that? It should be a review.